G'day viewers, this episode is a companion artifact to episode 106. If you have not watched episode 106, please pause this video presentation and review it before proceeding. In this episode we are going to walk through the Reactor Design tab in our Quinta Essentia Spreadsheet Calculator. The first thing we will do is show you where it is and how to access it. The link to the Spreadsheet Calculator is shown on screen. Please navigate to this destination and click the Linked Data tab. Once there, you can very easily download the Microsoft Excel file as emphasized. Okay, let's now look at what it contains. Once you have downloaded the file and opened it, please select the Reactor Design tab and read all of the Spreadsheet Calculator instructions very carefully before proceeding. When you have read the instructions carefully, you will see that the spreadsheet contains 4 calculators. The first calculator appearing in the Reactor Design tab is the optimal solution, which comprises of 16 element 115 disks. Users are required to enter the mass density of moscovium only, as indicated by the blue cell. Once the mass density has been entered, the spreadsheet calculates all necessary parameters to fabricate a primary wedge, along with companion wedges appearing in the diagram adjacent to the calculator. 8 companion wedges can be fabricated from a single cone. It is important to mention that the manufacturing of multiple wedges does not require extraterrestrial knowledge. Appearing on screen is a standard manufacturing engineering solution with the objective of maximising material utilisation whilst minimising material loss. As it turns out, no material is wasted if the wedges are fabricated from batches of 5 cones. Okay, let's now look at the second calculator. Calculator 2 relates the number of disks in a stack of disks to the resultant primary wedge mass. Users are required to enter moscovium mass density via the first calculator and disk thickness via the second calculator, as indicated by the blue cells. Once the blue cells have been populated, users can simply read off by row the primary wedge mass associated with whatever stack of disks is of interest. The cells in the right-hand column have been configured to emphasize any solution approximating a primary wedge mass of 223 grams, as indicated on screen. Okay, let's now move on to the third and fourth calculators. Our spreadsheet calculator has been a work in progress over time. On our journey, we have encountered a number of key information sources along the way. One of those key resources has been Ken Wright, due to the fact that he met Bob Lazar in 2000. Hence, in order to continuously test the veracity of Bob Lazar's story, we utilise as many alternative sources of information as possible, and Ken Wright is one of those sources. Calculator 3 utilises Calculator 1 as a first step in the process flow indicated, by utilising the mass density value specified in Calculator 1. Calculator 3 relates to ambiguous statements asserted by Ken Wright. The purpose of this calculator is to determine if Ken Wright's use of the expression 223 gram pellet relates to moscovium disks. Users are required to enter disk diameter and thickness into the blue cells. Calculator 4 utilises Calculator 3 as a second step in the process flow indicated. Calculator 4 relates to ambiguous statements asserted by Ken Wright. The purpose of this calculator is to determine if Ken Wright's use of the expression 223 gram pellet relates to the primary wedge. Users are required to enter the primary wedge height to base ratio into the blue cell. Please note that at the bottom of Calculator 4 you can see a rounded red box which displays the specifications required to generate a 223 gram primary wedge. Okay, let's now move on to Project Gravator. As of the 15th of September 2024, Project Gravator has been supplied with significant dimensional information by Bob Lazar. However, this information appears to generate numerous issues. To circumvent these issues, we constrain the primary wedge mass, number of disks and disk thickness in order to proportion a scientifically consistent solution. The grey shaded cells you see denote random number generation. This has been done to honour a confidentiality agreement we have with the Project Gravator leadership. Going forward, precise dimensions for all components may be released by the Project Gravator leadership. However, for the moment, we have agreed not to disclose the dimensions provided to us. The unshaded cells are calculated via the electrogravimagnetic construct, that is, they are predicted values. Cells containing 223 or 10 are not EGM construct predictions. They are values provided by Bob Lazar. However, it should be said that the number of disks value provided by Bob Lazar could be 12 instead of 10. Apparently Bob was uncertain on this matter. Okay, let's now look at various tables of solutions we have compiled utilising Calculator 1 and 2. We shall commence by looking at tables 1 to 4. The structure of the tables should be clearly evident by reading the column labels. Tables 1 and 2 relate to the Potter and Storti limits respectively, whilst tables 3 and 4 relate to the optimal solution as defined by Calculator 1 and standard nuclear physics theory respectively. The yellow shaded cells indicate that the associated configurations also appear on Table 12. Please pause the video presentation and study the information provided. Table 5 specifies an assortment of possibilities, whilst Table 6 relates to the reverse engineering of Project Gravitor data. Table 7 relates to the reverse engineering of Ken Wright's model, and Table 8 relates to Bob Lazar's second island of stability claim. The grey shaded cells denote randomly generated Project Gravitor data or specific configurations associated with randomly generated Project Gravitor data. Please pause the video presentation and study the information provided. Table 9 relates to Joe Vanetti's mass density claim, which has supposedly been endorsed by Bob Lazar. However, it should be stated that we have been unable to find any specific instance in which Bob Lazar has actually claimed the mass density of element 115 to be 31.5 grams per centimetre cubed. Tables 10 and 11 relate to the reverse engineering of Project Gravitor data. Please pause the video presentation and study the information provided. Table 12 is a collection of the 10-disc and 12-disc solutions appearing in tables 1 to 11. We will take this opportunity to remind viewers that the grey shaded cells denote randomly generated Project Gravitor data or specific configurations associated with randomly generated Project Gravitor data. Please pause the video presentation and study the information provided. Okay, let's now forensically examine what Project Gravitor says about the primary element 115 fuel wedge. As of the production date of this video presentation, the Project Gravitor website displays an image of Bob Lazar with a replica of the element 115 reactor. Since this is publicly available information, we may share dimensional information which we have been able to extract from the image. By executing relative measures as appears on screen and utilising the width of my own finger as a frame of scaling reference, we may estimate the dimensions of the primary wedge as appears in Table 13. Please pause the video presentation and study the information provided. Let's now look at our final table. Table 14 utilises the primary wedge base length estimate obtained from the Lazar image on the previous slide to estimate the number of discs utilised to fabricate the primary wedge. Our estimate of 10 discs is consistent with statements made by Bob Lazar to Project Gravitor leadership. Table 14 is generated by inputting mass density into Calculator 1 and disk thickness into Calculator 2 in order to obtain the primary wedge mass associated with the number of disks. The primary wedge height is obtained by multiplying the number of disks by the disk thickness. Please pause the video presentation and study the information provided. Okay, let's now summarise what we have learned. From this video presentation, we have learned the following. Number 1. Calculator 1 denotes the optimal solution which comprises of 16 element 115 disks. Users are required to enter the mass density of moscovium only, as indicated by the blue cell. Once the mass density has been entered, the spreadsheet calculates all necessary parameters to fabricate a primary wedge, along with companion wedges appearing in the diagram adjacent to the calculator. Number 2. Calculator 2 relates the number of disks in a stack of disks to the resultant primary wedge mass. Users are required to enter moscovium mass density via the first calculator and disk thickness via the second calculator, as indicated by the blue cells. Number 3. Calculator 3 leverages off Calculator 1 by utilising the mass density value specified in Calculator 1. The purpose of Calculator 3 is to determine if Ken Wright's use of the expression 223 gram pellet relates to moscovium disks. Users are required to enter disk diameter and thickness into the blue cells. Number 4. Calculator 4 leverages off Calculator 3. The purpose of calculator 4 is to determine if Ken Wright's use of the expression 223 gram pellet relates to the primary wedge. Users are required to enter the primary wedge height to base ratio into the blue cell. Number 5. Tables 1 to 12 articulate numerous primary wedge solutions formulated utilizing calculators 1 and 2. Number 6. Table 13 estimates the dimensions of the primary wedge as appears in the Project Gravitor image of Bob Lazar and the Element 115 reactor. Number 7. Table 14 utilizes the primary wedge base length estimate obtained from the Project Gravitor image of Bob Lazar to estimate the number of discs utilized to fabricate the primary wedge.